Hello everyone, welcome back. So today we are going to discuss about steady state AC analysis. So whatever analysis we have done with respect to circuits, that means mesh analysis, node analysis, or it be any algorithms like Thevenin, Norton, superposition. So whatever we have discussed earlier were in terms of DC. So the input that we have applied were with respect to DC analysis. So now today we are going to discuss the same analysis whenever we have AC as our input. So as you can see in the circuit diagram that is shown here, we have a AC source here. The remaining we have in the circuit inductors, capacitors and resistors. And as we know, the combination of resistance, inductance and capacitance together known as impedances. So let's see how to solve this type of numericals. So the consideration for the circuit analysis remains same. For example, suppose if you want to solve this, we can go for mesh analysis. For going into mesh analysis, we have three currents I1, I2 and I3, right? And as per our previous considerations, the current moves in clockwise direction, and in the question itself it is given as clockwise direction, and we have to determine the current I3 here in this example. Okay, so if we write down the KVL equation, so suppose for the KVL in mesh 1, so mesh 1 means wherever I1 current is flowing. So if you write down the equations, then it will be 20, the voltage, which will be positive because we are moving from negative to positive direction. Then next, as we already know, up across the impedances are negative, so it will be minus of, we can consider both of them together, 4 minus J4 into I1. Then next is minus J10, and we have both the currents I1 and I2 in that branch, so it will be I1 minus I2 because I1 is moving in this direction, I2 is moving in the opposite direction, so it will be subtraction, right? Then finally coming to the last impedance, which is 10 ohm multiplied by I1 minus I3. As we have seen, I1 is in this direction and I3 is in the opposite direction for 10 ohm. So this is the equation for mesh 1. Then writing similarly KVL for mesh 2 or KVL in mesh 2. So similarly we will be having minus, starting from this point, minus J10 into, this time it will be I2 minus I1 because we are working in second loop. Then it will be minus 10 angle 30 degree, and then again it is minus 20 of I2, then finally minus of 4 minus J4, and the current is I2 minus I3 equals to 0. So we have the second equation also. Let's move ahead. So KVL in mesh 3, so it will be, consider from 10 ohm, so it will be minus 10 I3 minus I1, right? Then we have minus of 4 minus J4 I3 minus I2, and below is 20 into I3 equals to 0. So we have three equations, three unknowns, so we can solve it easily. In order to solve this type of numericals, so we can write down the equation in this format. So I1 plus I2 plus I3 equals to whatever with the variable. So from the first equation, we'll be getting it as I1 term with 14 plus J6. I'm directly writing the value. Then next we are having minus of J10. Then I3 is minus 10 equals to 20 angle 0. We have this value. So this is for equation 1. Then moving for the equation 2, so it will be minus J10 for I1. So 24 plus J6 I2. Then I3 is minus of 4 minus J4. So minus of 4 minus J4 equals to minus of 10 angle 30 degree. Okay. Then finally for the last equation, it is minus 10. Then we have for I2 minus 4 minus J4. So minus 4 minus J4, minus minus will be plus. Then finally I3 will be 34 minus J4. Right. So now we can write this equation in terms of a matrix form. So if you write it in a matrix form, as you can see here, so now what we have to do is we have to determine the value of I3. As per Cramer's rule, if we determine I3, so it will be delta 3 divided by delta, right? So what is delta 3? What is delta? So delta 3 is considering first two terms will remain same, then the third term will be replaced by or the term on the right hand side. So in order to understand Cramer's rule, so let us consider a small example. Suppose a of x plus b of y plus c of z equals to, suppose m. Then we have, let's consider all are 1. Then next term is 2 plus b2y plus c2z equals to n. Then variable is 3, x plus b3y plus c3z equals to o. So now if we write down this in matrix form, so it will be a1 b1 c1 a2 b2 c2 a3 b3 c3 multiplied by x y z, and on right hand side we have m and o. So as per Cramer's rule, if you want to determine x, then x is given by delta 1 divided by delta. Similarly, y is given by delta 2 divided by delta, and z is given by delta 3 divided by delta. So now here, what is delta? Delta is determinant of a1 b1 c1 a2 b2 c2 a3 b3 c3, and we already know how to determine the determinant. So it is a1 multiplied by b2 c3, then minus of b3 c2, then we have minus of b1, and we have, yes, so there lies a difficulty or there lies a confusion if you consider it in this format. So instead of that, we can also write it like this. I am repeating the first term here again, and if we do it, then it will be plus. So it will be c2a3 minus c3a2, which will be similar as if we consider the convention as minus of b1, then multiplying the terms like c3 a2 c3 minus of a3 c2, these two are same. So in order to remember or make it easier, so we can follow it like this, and just simply repeating the first term in the last and then repeating the same process. Okay, or otherwise if you are following this phenomenon, this also can be done. So whichever way you feel it better, so you can follow that. Then coming to the third term, it is C1, then A2B3 minus of A3B2. So whatever we are getting, that is the delta. Then if we determine delta 1, delta 2, delta 3, so it will be given as, see here, you may already know, but still I am showing it. So for delta 1, it will be given as the determinant of, now we'll be replacing the first term for delta 1 by m and o. That means the right hand side variables we'll be putting here, and remaining will remain same, b1, b2, b3, c1, c2, c3, and the equations also remain same as we have calculated it here. The process is same. Then delta 2 will be, now we'll be changing the second column, that means a1, a2, a3, then it will become m and o, then it is c1, c2, c3. Now correspondingly delta 3 will be a1, a2, a3, b1, b2, b3, and we'll be changing the final column m and o. So whatever we get with respect to this formula, with respect to this calculation, so will be our answer. And then finally x will be delta 1 by delta, y will be delta 2 by delta, and z will be delta 3 by delta. So similarly, if we put it here, then this will be, so now for delta 3 we'll be changing these values, so remaining will be as it is. So minus j10, minus 10, then minus j10, then we have 24 plus j6, and this is minus 4 minus j4, and finally we'll be putting here 20 angle 0, this is minus 10 angle 30 degree, and we have this is 0, so determinant. Then below we have directly on the left hand side. Now if we solve this as we mentioned it here, so if we solve it similarly, then so I3 equals to, so for the upper term or the delta 3 term, so first let us calculate the delta 3. So for delta 3 it will be 14 plus j6, then this two term will be 0 minus of this two negative term, so it will become positive. It will be 4 minus j4 into 10 angle 30 degree. Then next term will be minus j10. So if you follow as per our discussion, so this will be minus j10, then minus minus will get cancelled, so it will be 10 angle 30 degree multiplied by 10, then this term will be 0, then finally the last term is plus 20, this is plus j minus 10, don't get confused. So this will be minus j10, minus and minus will get cancelled, so this minus will not be there, so this will be j10 into 4 minus j4, then minus, and that minus and this minus will get cancelled, so minus minus plus, so it will be 10 into 24 plus j6. So now in order to solve this, as we know, for multiplication of these terms we have to convert them into polar, and for addition and subtraction we have to convert them into rectangular. So if we do it and solve this, then it is the answer that we are going to get for the whole term, that means I3 will be 0.44 angle minus 14 degree. So I hope you have understood how to solve this type of numerical. So let me explain again. So first what we have done, we have written the KVL equations, first equation, second equation and third equation. Then we have determined the corresponding equation with respect to I1, I2, I3 format, right? Then putting the variables in the matrix form, the equation can be written as in this format. Then we determine I3 by determining delta 3 by delta. So what is delta 3? What is delta? That we have discussed here. And then just solve the numerical. So similarly, we have written the equation, and then in order to find out the multiplication and addition, as we have already solved this type of numericals earlier, that whenever we have multiplication of such terms, that means term containing real or imaginary part, then we have to convert them into polar form, and whenever we have to add or subtract, then we have to convert them in rectangular form. For example, if we are going to solve this multiplication, then we have to first convert this into polar form, then multiply this two, and then again whatever we are getting, that will be multiplied with polar form of this one, this term. So for determining polar form, suppose we are determining polar form of this one, so it will be, in the calculator we give it as 14 comma 6. So whatever we are getting, that will be the value we have to put here, right? So by processing this, we can get the answer. So now let us consider another numerical with node analysis. Let us consider node analysis. So here in the circuit, we have to determine the value of VA and VB. So in order to determine the value of VA, VB, we can simply take help of node analysis and determine the values, right? So as you remember, in node analysis, what we have considered is the current is always coming out of the node. So whenever we are considering node analysis, the current is moving out of the node. That will be the direction of the current. So as per that, if you write down the equation, so applying for node A, so it will be VA minus 10 angle 0 degree divided by resistance or impedance, which is J6. Then plus we have VA divided by minus J6. Then we have third equation as VA minus VB, third part is divided by 3 equals to 0. Then for node B, so we have VB minus VA divided by 3. Then we have VB divided by J5 minus J4. Then plus third term is VB divided by J4 equals to 0. After simplifying, we have this term as 0.33 VA minus 0.33 VB equals to 1.67 angle minus 90 degree. And after simplifying this term, we have minus of 0.33 VA, then plus 0.33 minus J 1.25 of VB equals to 0. So this is the second term. So now after solving these two equations, we can determine the value of VA and VB. So if we add these two equations, let us consider 1 and 2, then VA will get cancelled, remaining will be VB. So by adding these two terms, we have VB as 1.67 angle minus 90 degree divided by J 1.25. So after solving this, we'll be getting the VB as 1.34 angle 0 degree. So this is the value of VB. Similarly, we can determine the value of VA by putting the value of VB in one of the equations. So let us consider this equation. Here we are putting the value of VB. So we'll be getting the value of VA, and it will be coming out as 5.24 angle minus 75.17 degree. So this is as simple as that. So for the circuit, we have the value of VA and VB here. So like this, we can solve any numerical considering nodal analysis. Now in the same format, like as we have discussed today, for node analysis and mesh analysis, we can similarly solve for AC analysis. That means considering AC sources. So we have discussed two numericals today. So similarly, like this, we can also solve for Thevenin, Norton, superposition, or maximum power transfer theorem. So those numericals we'll be considering in our next class. So I hope you have understood this and you will be able to solve numericals using these methods. So thank you for joining and listening so far. So if you have any doubt or if you have any questions on this topic, then please put it in the comments and we'll like to address them in our next class. So thank you for joining.